Ferrari intends to get back on top in the upcoming Formula One weekend. This will not be easy, but the Italian team has worked hard. Many hours were spent on the simulator in order to increase the understanding of the new updates because the goal for the 2024 Austrian Grand Prix is to optimize the updates from Spain and consequently improve the performance of the SF-24 single-seater. According to team principal Frederic Vasseur, it can be done as the data collected at the Circuit de Catalunya confirmed the effectiveness of the updates. Everything worked, and the historic Maranello team saw firsthand what had been hypothesized in the design phase. Austria, as we were saying, is the home of Red Bull, a peculiar old-fashioned track where McLaren could even start as the favorite. They will need to maximize the package to beat the impressive Max Verstappen, because the Dutchman is showcasing great talent that allows the RB20 number 1 to continue winning. Then there's also Mercedes, which cannot be forgotten. A team that seemed lost until last month, until it showed in Canada that the performance step exists and can be transferred to other tracks without too many problems. As predicted, Red Bull has mounted the medium-high load specification, recently used in the Imola and Canada Grand Prix. The wing features a rather pronounced leading edge and a fairly large frontal area, similar to the Ferrari version. The Italian team, in turn, is reintroducing the medium load specification used most often during the championship, with the latest version revised in the wingtips area in the Imola race. As we can see from the images taken in the Red Bull Ring pit lane, the thickness of the leading edge on the SF-24 wing is more contained. The objective is to generate a smaller pressure difference between the bottom and top. Ferrari wants to optimize top speeds while maintaining the necessary load for the stretch between turn 6 and the finish line. This is the specification they know best. The technicians have discarded the medium-high load version, believing that the current downforce installed is sufficient through the appropriate combination with the beam wing incidence. To stabilize the rear, the red team needs to limit the floor excursions at high speeds. Therefore, a stiffer rear setup should be the chosen path with the setup. This way, Ferrari aims to consolidate the part of the circuit that includes the type of corners most suitable for the Italian car. We are referring to the support turns at a speed range where the SF-24 has always found plenty of grip and stability. Logically, the theory makes sense, although we have to wait for confirmation on the setup, which must be able to maximize the strengths. All this considering that both prancing horse cars will feature the new floor we observed in Spain. Red Bull will be able to benefit from a few extra points of load, given that the two RB20 cars can undoubtedly sacrifice some top speed points thanks to the excellent drag resistance of the Austrian cars. This aspect will be very convenient between turn 2 and turn 3, but also in traction at turn 1 to stabilize a rear that in certain circumstances lightens too much on entry, where the balance is still not perfect. The better aerodynamic penetration allows for greater loading of the second axle, and the problem is contained. As for the surprising McLaren team, we can see that the wing specification chosen for Austria is the one already used in the last two F1 World Championship rounds, Canada and Barcelona. This version can produce a medium load level thanks to the not very pronounced leading edge. The second flap has a very high curvature, capable of reducing the local incidence in the outermost area. This aspect should consequently increase the total efficiency of the car, undoubtedly a point in favor of the Woking team. Regarding Mercedes, examining our comparison made through the shots from the 4.318-kilometer Red Bull Ring in Spielberg, we notice that the Brackley technicians have chosen to bring what they consider to be the most efficient specification at their disposal. The W15 wing offers a fairly pronounced main plane in its central portion, where the load generated by the car tends to be concentrated. The pressure distribution has a decreasing trend towards the outer profile, to contain the losses due to induced drag. Now let's analyze the key track characteristics of the Red Bull Ring ahead of this weekend's Austrian Grand Prix. The Red Bull Ring, the home track of the eponymous Austrian team, spans a total length of 4,318 meters with 10 corners, 7 to the right and 6 to the left. In Austria, the F1 sprint format will return for the third time this year, engaging the drivers with 2 races over the weekend. The sprint race on Saturday will be 24 laps, while the main race will be 306 km long for a total of 71 laps. As can be seen from the layout, the Spielberg track is very fast. The average speed on a push lap is around 240 km per hour, mainly thanks to the 3 main straights. Top speeds exceed 320 kilometers per hour with the help of DRS. The corners that will challenge the drivers are 7 and will be taken at very different speeds. Generally, the aerodynamic setup will favor speed at the end of the straight, with configurations similar to those seen in Miami. The Italian tire manufacturer Pirelli brings the softest compounds of its range to Scuderia, C3 hard, C4 medium, and C5 soft, and historically, a two-stop race cannot be ruled out. These tires offer maximum performance to the drivers, but at the same time, the soft compound wears out more easily. This is due to the medium-low aerodynamic load that favors tire slippage during traction, increasing wear. At the start of the Grand Prix, there is a distance of about 300 meters between the pole position slot and the first braking zone, with the road tending to rise. Compared to what was seen in Spain on Sunday, a comeback from the back will be difficult. The poleman will have to defend against the driver beside him, who, starting on the inside, has a chance by extending the braking into turn 1. During a push lap, it will be crucial to manage the hybrid part, minimizing its use on the main straight to benefit from it on the following straights. The first right-hand turn is tackled at about 150 kilometers per hour, a medium-speed corner that requires a combined aero-mechanical effort. The difficulty lies in the slight negative banking, which, with a low rear load configuration, could facilitate oversteer. For this reason, the work done by the suspensions is crucial, with a rear not excessively stiff to aid traction. Upon exiting the corner, drivers stay inside the yellow sausage curb that delimits the track to avoid track limits. Shortly after the exit, DRS can be opened, making the most of the aerodynamic efficiency of the car and the boost provided by the hybrid system, which are crucial in Austria. Turn 3 is approached at over 320 kilometers per hour and is one of the most favorable overtaking points. The braking zone forces drivers to slow down their cars by about 250 kilometers per hour. However, the braking phase is facilitated by the 12% uphill gradient. The braking force component, which shifts the car's weight forward, is less. This is due to a component of the gravitational force directed towards the rear of the car, being on an inclined plane. Exiting turn 3, considering the minimum speed at the center of the corner, mechanical grip predominates over aerodynamic grip. The entry phase is sacrificed by postponing the apex to get on the gas with less steering angle. Like the first turn, this corner is rear limited, and the work of the rear suspension is crucial to limit understeer. After turn 3, the main straight in the central sector leads the drivers to turn 4, with the possibility of opening DRS. The hybrid strategy should optimize electric power in acceleration, reducing it in the second part of the downhill straight. The fourth change of direction on the circuit is a downhill hairpin that, for the opposite reason to that described for turn 3, requires greater braking force. Braking occurs shortly after the 100-meter board, and once again, the apex is anticipated to maximize the exit. The acceleration phase occurs with steering angle, and both axles of the car are stressed. The front axle must maintain the car's direction without slipping, while the constant right-hand bend at the rear can induce oversteer. The last 4 corners of the track are medium fast with not excessively long support periods. The mechanical part of the car does less work, although a precise front end that follows the driver's inputs is still important. Turns 6 and 7 are similar, both in terms of minimum speed at the center of the corner and curvature radius. Turn 7 requires a longer support period, which, especially with fuel load, forces managing the cornering speed to avoid overheating the tires.